Now members, we are going to see how do we draw a histogram with classes with unequal class intervals. So I'm going to use both methods, but now the common method used is this one on the frequency density because it's not that complicated like this one. Here people are getting confused the way you calculate the number of times with this, but I'm going to do this one, the common one, and I also do that on the same lesson. So the histogram is plotted with frequency density or the standard frequency on the vertical and the class boundaries on the horizontal axis. So the mode is given by now the lower class boundary plus the frequency density above the difference, then the frequency density above the difference, then also that one below. Here it's above, then this one below, where f is the frequency density. And we say the class with the most or with the highest frequency density or with the highest standard frequency becomes our model class. So use the table below to calculate the mode and draw a histogram using the frequency density and also the standard frequency. So I'm going to do both so that you get easy. Now, here I'm starting my story. I calculate my, you don't need to write this again. All you need is to get, now from here, you easily calculate your class boundaries. So my class boundaries, you subtract here 0.5, the adjustment scale factor, the adjustment factor. Subtract 0.5 here, add here. Subtract it here, add it here. 0.5. Subtract 0.5, add 0.5 there. So that's what we are doing. Now after that, we need now to calculate the mode. Now, here we say to get the frequency density, we get frequency divided by the class boundaries. How do you get the class boundaries now? If you, the class intervals. If you have now class boundaries, to get class intervals, what you do, you just get this minus this. You don't add this time around. If you have class boundaries, you don't add that one. All you do, you get this minus this, this minus this, this minus this, this minus this, then this minus this, when you have class boundaries. But if you have just classes, if you have this, you say this minus this, then plus 1. But when you have class boundaries, you don't add it, it's already perfect. Now, how do you get the frequency density? We get frequency divided by the class intervals, So you say this divided by this, you get this. 5 goes here 3 times, this goes here 2 times, once, that. Now, when you come to the, from here up here is the standard frequency density, then from here up here is the standard frequency. How do you get to the end? People are confused about the standard interval. The standard interval, in most cases, is the smallest, and the one which is, I think this is common, 5, 5. There are 2, but now this is 10 and also this is 10. This is 5 and this is 5. Now, we take the smallest, which is 5. Always, it should be smaller compared to others, if they are 2 equal things. Now, what we do now to get this end, we get the class boundaries, we divide it with the standard interval. Our standard class interval we have seen is 5. Then we get all the class intervals divided by that, which is 5. So now the other time we divided with the 10 because 10 was the smallest and it was the commonest. Now here we divided with 5 because it's the smallest. So now we get this 5. 10 divided by 5 we get 2. 5 divided by 5 we get this. 5 by 5, 5 by 15 by 5, 3. 10 divided by 5 we get 2. Simple. Now this one is very last to get the number of times this standard interval goes into these class intervals. Then after this n, you divide it with the frequency. So now you get this n divided by this, you get 7. This by this, you get 15. This by this, you get this. This by this, you get this. This by this, you get this. I think that's why people don't like to use this because it confuses people sometimes. But if you are perfect, there is nothing much in it also. Okay. So now after that, we come and first get our class, the mode. So if you calculate the mode now using this, we use this formula. We don't use now, here we don't use the frequency, we use now the frequency density. So now from there, it's like we knock out the class with the highest, either frequency density or standard frequency. And you can see this is the one with the highest. I think you see. And you see that even if you are in this will be the highest. So now meaning, so what are you substitute? The lower class boundary here is 44.5. Then plus this one FDA. Our FDA, we get this 3, then minus 1.4. And I swear to subtract there, you get 1.6 over 1.6, then plus, this will be 1.6. Then our FD below, we get 3 minus this represents the below, which is 2, and so that we get a 1. That's why I'm having 1. Then the class interval of this is a 5. Then when you press this on the calculator, I'm not sure how you press it. What you do when you're pressing, you first say this 1 point, you say this plus this 1.6 plus 1. Don't YZ. Then you say divide by 1.6 divided by answer. Then after you multiply times 5. Then after you add, you say plus 4.5. So the answer you get to give 4 decimal places. I'm getting 47.5769. Or if we are using this, we will be having now our mod would be still the same class. LCD 44.5, then plus. Now we use this one, so this time this minus this. Now here our standard frequency above, we get this minus this will be now 15 minus 7, which will give us 8. So here we are having 8 over 8 now plus the standard frequency below, which will be, now we get this minus this 15 minus 10, which will be, now this will be a 5. So 5 then times the interval remains that. So this will give us this. You say 8 plus 5 equals 8 divided by the answer equals times 5 equals plus 44.5 equals, I think you see, we get the same answer, 47.579. So either use this method or use the other. Here we are using the standard frequency. Here we are using the standard frequency. Here we are using the FD. So the same answer, exactly the same answer. So whatever you want is what you will use. Or alternatively, or you can use the other for standard frequency. Okay, so from there now we come on our sketch. Now we say we sketch FD. I'm going first under the FD against the class boundaries. Now here you need to be careful with the classes. You represent that carefully. So it's that now my scale I'm going to use is 1 1 for every 2 centimeters, but because of my blackboard, for you can use a bigger scale. So it's that now this is my frequency density. You see, I have 1, there is 23. So I'm going to say I'm going to use it from 1, 0, 1, 2, and 3. Now here, this class boundary, its class width was 10. That's why here I'm adding 2 centimeters. The next from here to here, it was a 5. That's why I'm adding 1 centimeter. This one is smaller. Even this one was 5. But from here up to here was 15. That's why from here up to here, there are 3 5s like that. Then here there are 2. Then from here up to here, that is the case. So always the classes here go with their width. Okay. So I think I hope I'm clear there. Then we start plotting. So you start this one, the first class goes with 1.4. 1.4 is, I think, somewhere here. So you get your ruler now. 1.4 is somewhere there. Then our class is there. The first. From 34 to 44, that is what we have there. Then I come to the next. The next is from 44.5, from 44.5 to 49.5, the width there is 3, so it's the highest. So I go to the highest there. It's there. It's taken between and then to this. My FD there. All this we are using a ruler. Then from 49 to 54.5 we have 2. From 49 to 54.5 we have 2. Our 2 is here. Our 2 is there. Then you plot it there. Then you do this. Then from 54.5 to 69 we have a 1. So we have a 1. Now this one is up 69. We have a 1. It's the longest. It's the one which is having the widest interval. I think you can see. Then this one is 1.6. From 69.5 to this is 1.6. But the bound is 1.6. I think 1.6 is slightly above for this. So 1.6 is going to be somewhere there. Okay. For your graphs, I think it's very clear. We do all this work on a graph paper. I warned you already about that. Graph paper. So that's the case now. You see that the class, these class boundaries are, this one is 10, this one is 5, this one is 5, this one is 15. So it's 3 times 1, 2, 3. It's the widest. Then this one is, so this one is equal to this is equal to this one is equal to this. So that's how we plot frequencies. They write this in full that my stress was small. Then here we are plotting against classes. I told you what they give you in the question is what you put. So if they give you heights, you put heights. If they give you years, ages, weights, that's what you put there. Now let us come to the one where we are using the standard frequency. My standard frequency, you see, the biggest is, the smallest is 7, the smallest is 5, the smallest is 5, and the biggest is the 15. That's why the scale, the proper scale would have been from 2 to 2 centimeters, but from 0. But because mine can't fit here, that's why I started from 4. But we indicate that we are starting from 4. Okay, even the same case here, the width, the widest, like that. Then we plot the first class also against classes, all the class boundaries. So from this to this, it was 7. Our 7 is here. Our 7 is in the middle there. You draw that. It's in the middle. Then I come to my 15. So it's that the next is 15. From this to this is 15. You come to R15, somewhere there. R15. So that's R15. From there to there. I think you can see this is my 15, the longest. 15 there. Then the next is 10. You come until your 10 from here up to here is 10. So our 10 is here. Is 10. I think you can see where there. My 10 is there. The same idea. Then the next is 5. 5. The next is 5. So 5 is here, between 4 and 6. That's where our 5 is. Between 4 and 6. That's where our 5 is. This one is shorter because of the scale. Then the next class is 8. Our 8 is here. 8. So 8 from here up to here. So that is the difference between, when it's the standard frequency, you indicate standard frequency. This one is the standard frequency density. That's the difference. Don't waste time shading. In math, you don't need. Why are you shading? Don't shade that down when you're doing geography. But here, don't shade. So that's it, members. Now we are going to go to bounded classes. See you there.